Okay, so our last section for this week is 2.3. Okay, yesterday, what two properties did we look at with solving inequalities? What two operations did we use? Josh?
Addition.
Yeah, we did addition and subtraction. Okay, today we're going to do multiplication and division. Okay, there's only one trick when you do multiplication and division, and I'm going to make a little table to kind of show you what can happen when you multiply and divide. Okay, so this part, I just want you to just read this. You don't have to write it. But this is for equations. Okay, not what we're doing today, but we did do this back in chapter 1. Okay, the multiplication property of equality allows you to multiply both sides of an equation by the same number. So like if you had something like this, the way you would solve it is you'd multiply both sides by a certain number. Anybody tell me what number you'd multiply by here? To get x by itself?
4.
Yeah, multiply both sides by 4. And there's your answer. X equals 10 times 4. Well, we're going to do kind of the same thing today. Okay, we're going to multiply both sides, except it's not going to be an equal sign. It's going to be an inequality. Okay, so we'll have either less than, greater than, something like that. Okay, so as I just said, we're going to extend that same idea to inequalities. Okay, so we've got a table, and I want to try doing some different operations to the original inequality and see if it works. All right, so let's start with the original. 3 is less than 4. Am I starting out with something that's true? Is 3 smaller than 4?
Yeah.
Yeah. Okay, so this everyone agrees that's true. Let's multiply each side by 5. Okay, and see what happens. What do you get if you do 3 times 5? 15. What about 4 times 5? 20. Okay, so all I did was multiply each side by 5. Is the new inequality true or false? True. Okay, so it looked like it worked fine. We multiplied both sides by the number 5, and we still ended up with something that's true. Okay? Let's try this one. Okay. Negative 4 is greater than negative 20. Okay? Is that true? Yeah. Negative 4 is a bigger number than negative 20. Okay, so we're starting out with something that's true. I'm going to divide each side by 2. And I want to see if it's still true. Okay. Bay, what's negative 4 divided by 2?
2.
Yeah, negative 2. And what's negative 20 divided by 2? Careful, not 10, but negative 10. Is negative 2 greater than negative 10? Yes. Okay, if you're thinking on a number line, negative 2 is to the right of negative 10. So yep, that's still true. Okay, so far everything seems fine. Okay, well, let's see what happens here. Negative 5 is less than negative 3. Okay, first of all, is that true? Yes, negative 5 is a smaller number than negative 3. Negative 5 is more negative. Let's multiply each side by negative 1. Okay, Trenton, what do you get if you multiply the left side by negative 1? 5. And how about if you multiply the right side by negative 1? 3. My new inequality, 5 is smaller than 3. That's false. So something didn't work here. All right? Even though we multiplied both sides by the same thing, something went wrong. Does anybody know what was different about this one than the first two? If not, we'll try one more, and I think you might know what happened. Yeah?
that you started out with two negatives, and then when you multiply by a negative, everything that you multiply by a negative is positive?
All right, so yeah, it has to do with what we multiplied by. Okay, it's okay if we start out with two negatives, because sometimes that can still give us something that works. But the key is if you multiply by a negative, you have to be careful. Okay, and I'll explain what we have to do. Let's try this one. Does everybody agree 18 is bigger than negative 6?
Yeah.
Yep. Let's divide each side by negative 3 and see what we get. Okay, so let's take 18 divided by negative 3. We get negative 6. And let's take negative 6 and divide by negative 3. I get 2. So I divided each side by negative 3. And I checked it on the calculator, so I know I did it correct. Is this inequality true or false? That's false. A negative number is not greater than a positive. Negative 6 is not bigger than 2. So something went wrong again. Does anybody know what it had to do with? Yep.
Dividing instead of multiplying.
Dividing by what?
Negative 3.
-3. That's the problem. Okay, you divided by a negative. So we run into some problems whenever you multiply by a negative or divide by a negative. And I'm going to show you how we can fix that problem to make sure when you do it, you still get something that's true. Okay, you don't want to get something that's false because that means it's wrong. Okay, so this, you don't have to write this part. That's just summarizing what I just said. Okay, from the table, hopefully you notice that if you multiply or divide each side by a positive, okay, that worked perfect. Okay, when we multiplied by positive 5, divided by positive 2, we didn't have any problems. This is where we have the problem. If you multiply or divide both sides by a negative, we got a false inequality. Okay, so multiplying and dividing by a negative, that gave us a problem. So we can't have that. We gotta fix that somehow. Okay, and that's what we're gonna fix right now. Okay, so on your sheet you've got two properties side by side. Okay, multiplication property and then division. So let's start with multiplication. Okay, the first part you should already have printed on your paper. If you multiply both sides of an inequality by a positive number, you get something that's equivalent. You get something that works. Okay, so that's fine. But here's the part you need to write down. If you multiply both sides by a negative, you have to remember to do something extra. If you multiply both sides by a negative, you have to flip the inequality. Okay, so if you multiply both sides of an inequality by a negative, you have to flip the inequality. We already saw what happens if you don't. If you don't flip it, it's going to come out false. And false means wrong. Okay? So what I'll do is I'll go back to the table. Let me flip the inequality and let's see if that really works. Okay, so if I go back, okay, instead of writing this, let's flip it around and write that. If I flip it, does it work now?
Yes.
Yes. 5 is greater than 3. Okay, flipping it makes it true. That's what we want. How about this one? If I flip that around, is negative 6 less than 2? Yeah. Okay, now it works. Okay. Now, do you think you want to flip it when you multiply by a positive? No. Because when we multiplied by a positive, we didn't have any problems. So if you multiply by a positive, don't flip it. Okay, just leave it. Only time you have to do this flipping is if you multiply by a negative. Okay, and we'll practice. We'll do some problems where you have to do that and somewhere where you don't. Okay, and the division property of inequality, pretty much the same thing. Okay, you can probably already guess what you need to write under the if. You just have to change one word. Okay, so if we divide both sides by a positive, we're all set. Don't change anything. Only time you need to flip the inequality is if you divide by a negative. Okay, so if you have an inequality and you divide both sides by a negative number, flip it. Okay, have it point the other way. And as far as like directions and notes, that's really pretty much it for the notes that I need to tell you. Okay, so now we'll practice solving a few problems. Okay, and as we solve them, we'll also graph them. Okay, just like yesterday. Okay, does everybody have these two statements? What you do if you divide both sides by a negative?
I do.
And what you do if you multiply by a negative? They're the same thing. All you have to do is change the word multiply to divide. Okay, anybody else need to copy that down? Okay, so let's try example 1a. Directions say solve and graph. Okay, 7x is less than negative 56. Okay, so if it helps, try to think of those steps that we used when we solve equations. Okay. First, we did simplifying, okay, if we needed to. We're still doing basic inequalities. We haven't really got to ones where you have to do distributive property or where you have to combine like terms. Okay, that'll be next time. Okay, next academic week. So now I don't have any simplifying. How about adding or subtracting? Is adding or subtracting a number to both sides here going to help you to get rid of that 7? What do you think, Kyle? What do you think? Not sure? Can anybody tell Kyle what operation am I doing with the 7 and the x? Those two things are being what? Multiplied. So what operation cancels out multiply? Division. All right. So are we using addition or subtraction here? No. Nope, no addition or subtraction this time. All right, so we don't have to worry about that. Okay, so I told you we're going to use division. Who can tell me what I divide by? Remember, the goal is to get rid of that 7. Yep, Liam?
7.
Yeah, you can divide by 7. Divide by 7. 7 divided by 7, that cancels out. Okay, and I get x. And let me do negative 56 divided by 7. Okay, I get negative 8. And now I didn't put the symbol in because my next question is, do I leave it or do I flip it? Okay, what did I divide both sides by? What kind of 7? A positive 7. Okay, so even though there's a negative on the other side, I don't care about that negative. I didn't divide by negative 56. I divided each side by positive 7. So when you divide by a positive, do you flip it or do you leave it? Leave it. Okay, if you divide by a positive, leave it the way it is. And that's the answer. Okay, so we solved it. Now we got to graph it. So let's set up our number line. Again, don't worry about putting in every single number from 0. Just put in 3 numbers. -7, -8, -9. Okay, I got to decide on my circle. Open circle. What number? -8. Now, I guess I should have asked, is this inequality set up the way we want? Yeah. Letter, symbol, number. If you set it up that way, it tells you which way to shade. Okay, so how about Vanessa? Which way do I shade? Yeah, shade to the left. And that's it. Okay, so the only difference between these problems and yesterday, you're using multiplication and division to solve them today, not addition and subtraction. Okay, any questions on example 1A? Nope. All right. Let's try example 1B. Okay, take a minute and try that one on your own. Okay, try example 1B on your own. Okay, I'll give you a hint. It's only one step, just like the last one. You just have to do one thing. But make sure you follow those rules. All right, so Liam's going to come up and show us how to solve 1B.
Do I have to explain it, or can I just do it?
You can just do it, and I'll tell people what you're doing. So he's looking at his paper. He's drawing a line. Looks like he's dividing the left side by -3. The right side by -3. Perfect. He's going to do the same thing on both sides.
Hope I did this right.
So he's got x. Looks like he flipped the sign, and he did 21 divided by -3. So before he graphs that, let's check and see. Does everybody agree with that?
No. No. I played yourself.
Oh, you know what? I think I said he flipped it. He kept it the same. Kept it pointing the same way. Okay, I like this. Okay, we divided by the -3. 21 divided by -3 is -7. I like that. What's the one thing we have to do that we forgot here? Right. What did we divide by? -3. Okay, so since we divided by a negative, we got to take that inequality and flip it. Okay, how many people remembered to flip it on this one? Okay, it's hard to, well, it's easy to forget, because if you forget to flip it, it's not like something weird happens and, it's like something clear. You can say, oh, I forgot to flip it. There's no warning. There's no reminder that you should have flipped it. It just, you get it wrong. Okay? So you just got to remember, if you divide by a negative, flip it around. All right. So now I'll help us finish this up and graph it. Let's do our number line.
Do we have to do the back?
Are we doing the back? Yeah, we're going to do the back. There's only one problem on the back, I think. Maybe 2. 2?
There's like 50.
50. Example 2 and 3, right? Yeah. 2 examples. All right. So what kind of circle do we need this time? Closed. And shade to the left. Perfect. Shade left. Okay. So in both of those problems, what operation did we use to solve it? We used division, right? Division in the first one, division in the second one. So what do you think I'm going to do in the last 2 problems? Instead of division, we're going to use multiplication. All right, so let's do this one together, and then I'll let you guys try 2B, and somebody can put that on the board. Okay, as you look at this, what do you notice? Something here that I kind of don't like, that I might have to fix it when I'm done. Okay, so we got a fraction. What else? Something else that we don't like. No, not this. something about how it's set up. Emma?
You want to switch it?
Yeah, the variable's on the right. Okay? So when the variable, Jordy, when the variable's on the right, you've got two choices. Either fix it now, or you're going to have to fix it at the end. Okay? So far, we've been fixing it at the end, so we'll keep doing it that way.
What happened to the teacher?
Who?
Teacher is supposed to be.
Mr. Roy.
Mr. Roy's out.
No, not.
Oh, no, there's nobody for today. There'll be somebody tomorrow. Yeah, Mr. Pelletier will be here. Okay, so if you guys need to come out tomorrow to take a test, Mr. Pelletier, he's going to come up and he's going to take people out. All right. Do I have any simplifying here? Any distributive property, like terms, anything like that? No, not in this one. So what operation am I doing with the x and the 2? We're doing division. So somebody tell me what's the opposite? Multiplication? So what am I going to multiply both sides by? 2. Multiply by 2. Multiply by 2. What kind of 2 did I multiply by?
Positive.
Positive. So keep that in mind for a second. We're going to come back to that. 2's are gone. I get x. What's 2 times 5?
10.
10. And you guys told me I multiplied by a positive.
Positive.
Flip it or leave it?
I just said do that.
Don't do what? Don't flip. If you multiply by a positive, leave it. All right. Now we've got something else to think about. Okay, this is not set up the way I like it. Okay. Where do I want the x?
On the other side.
And where do you want the 10?
On the other side.
On the other side. Now, when you rewrite it, we have to flip the sign.
One point face the
Right?
x.
The reason we're flipping it here has nothing to do with dividing or multiplying by a negative. Okay? It's just because we didn't like the way it was set up. We wanted to put the x and the 10 on different sides. Okay? Why do I do that? Why does that help me when I want to draw it? Jen?
Because it tells you which way the line goes when you imagine it.
Right. If you do it this way, it tells me which way to draw the arrow. Okay? If you don't do this on the test, I'm not going to mark it wrong, but most of the time when people don't do this, they shade the wrong way. And then they lose half credit. Okay, so I'm going to do my number line. And Jordy, what kind of circle?
Close?
Why?
I don't know. No.
It's open. It's open.
Okay, why is it open?
Because it doesn't have a
Magic.
Because of magic? No, not because of magic.
magic unicorn.
Because of kaboom.
Why do we do an open circle on this one, Kyle?
It's not equal to.
Yeah, you don't have the equal to. Okay?
Oh.
If you don't have the extra line under it, don't take the extra step and fill in the circle. That's how I remember it. Okay? If I have the extra line, I got to do something extra and fill in the circle. And now shade which way? To the right. All right. So any questions on 2A? All right. So we got 2B, example 3, and then we're done. Yep. One more example after this. What's that?
Then we can just stop.
And then I'm going to give you the homework. Actually, I'm going to give you the review for the test, which is the homework. All right, you know what? This one's a little tricky, so we might want to do this one together. What kind of number do I have in front of x? First of all, it's a negative, and what other kind of number? It's a fraction. Okay? Does anybody remember when you have a fraction in front of a letter, you multiply both sides by something, and it gets rid of the 2 and the 3 at the same time? It begins with an R.
Oh, I know.
Yeah? Yeah, reciprocal. Okay, so we're going to multiply both sides by the reciprocal. Hey, Jordy, what's the reciprocal? What's the reciprocal? How do you find that? Okay, I need you to make sure you're paying attention, okay?
Okay.
Vanessa.
It's just when you flip the fraction.
Yeah, it's just when you flip the fraction. Okay, that's all you do. Okay, so now that she said that, Jordy, what's the reciprocal of this fraction? Well, how'd she say to get it?
Oh.
Flip it.
Flip it.
So what do you get when you flip that? What goes on top?
The 3,
And what goes on the bottom?
2,
The 2.
2, 1, 3.
Okay? And that's multiplication. Okay, you might have noticed I put the negative with the 3. When you have a fraction, this and this, same thing. It doesn't matter if you put a negative in the top or in the bottom. Okay, a negative, I usually just put it in the top. And what am I going to multiply by on this side? Got to do the same thing on both sides. Emily?
Negative 3 over 2.
Negative 3 over 2. Okay, I've got a problem here. I've got this 12. 12's not a fraction. When I multiply fractions, I like to have all fractions.
Technically it is because you still put it over 1.
Yeah, you can always put it over 1, exactly.
It's a fraction now.
Okay, so now it is a fraction.
Yeah.
Okay, 3 in the top, 3 in the bottom. 2 in the top, 2 in the bottom. That's all canceled out. So x multiply straight across. What's 12 times negative 3?
What's the question again?
What's 12 times negative 3?
Negative 36.
Negative 36 divided by 1 times 2. 2. Now, I know I can reduce that. I'll worry about it in a second. What did I multiply both sides by? Negative 3 over 2. So I multiplied both sides by a negative. Do I flip it? How many people think I flip it? Yes. Okay. How many people think that that's the final answer? Negative 36 over 2.
It is not the final answer.
What can I do?
Reduce it.
You have to reduce it.
That's what I said.
What's negative 36 divided by 2, Antonio? Half of 36.
18.
18.
36. I'm thinking 6 times 6 36.
Positive or negative?
Negative 18.
Negative 18. Okay, any questions on that?
What's wrong?
Who can tell me why did I flip it again? Why didn't I just leave it the way it was?
Because of the
Kyle?
Because you timed it by a negative.
I times it by a negative.
Times it.
Okay? Or multiply. Yep, same thing. Okay, any questions before we do our last problem? Nope. Example 3, last one. We didn't graph it? That's okay. We've graphed, I think, 3 of the other ones. Yeah, don't worry about the graph on this one. All right, so last one. Okay, it says you earn $9.50 an hour at your summer job. Okay? They want you to write an inequality that represents how many hours you have to work to buy a camera that costs $247. All right. So, you earn $9.50 an hour. It's minimum wage? That's what it is? All right, so what do you know about the amount of money you earn? How much does it have to be in order to afford the camera? Not quite. How much money do you have to earn to buy the camera?
247.
Or more. Okay? 247 or more. Okay?
Ask your mom for some. Actually, it's tax, so it's.
Okay, so start out by writing the inequality, the amount of money you earn, AM abbreviation. The amount of money you earn has to be greater than or equal to how much? 247. Okay, as long as you make greater than or equal to 247, you can buy the camera. So, we make $9.50 an hour. How would you write an expression that represents how much money you make? Because you earn $9.50 every hour.
9 times, n times 950.
Sure. You could say 950 times, what'd you use for your variable? N. Where N represents the number of hours you work. Okay, so if you work 1 hour, how much money do you make? 950 times 1 hour. If you work 2 hours, you make 950 times 2. Okay, 3 hours, 950 times 3. All right, so have I done what they asked me? I wrote it. Okay, now I need to solve them. All right, so Marissa, how do I solve that?
Dividing 9.50
Divide by 9.50
on both sides.
on both sides. Okay, so let's use our calculator. Divide by 9.50, and we get 26. So that means you have to work how many hours? No, not 26. How would you say the answer here? How many hours do you have to work to afford the camera? Josh? How much?
1 day.
Oh, you can keep it in hours. Yeah, that is 1 day, 2 hours if you changed it to like days. But how would you say the answer? It's not exactly 26 hours. It could be at least 26 hours. Okay? Okay, so you have to work 26 hours or more. Okay, or as Emma said, at least. Okay. All right, so guys, hold on one sec, couple quick reminders. Okay, I am not after school today. Okay. The homework is going to be a worksheet. Okay, it's actually a review guide. Okay, it's going to cover everything that we did this week. Okay.